Classification in organic chemistry is necessary to characterize an atom or functional group. Classification can be a factor in determining a reaction mechanism, for example. Carbon atoms in alkanes and other compounds are classified based on the number of carbon atoms they are bonded to. For example, carbon atoms bonded to one carbon atom are called primary carbons, while carbon atoms bonded to two carbon atoms are called secondary carbons. Carbon atoms bonded to three and four carbon atoms are called tertiary and quaternary, respectively. Classification of hydrogen atoms, alkyl halides, and alcohols are based on the carbon to which they are bonded to. For example, hydrogen atoms, alcohols, and alkyl halides bonded to primary, secondary, and tertiary carbons are called primary, secondary, and tertiary, respectively. Let's do some examples. So let's do an example here where we classify carbons and hydrogens in this alkane. We'll start on the left. This carbon atom right here is bonded to only one carbon atom, and that's going to make this carbon atom a primary carbon. I'll label it as primary. The second carbon atom is actually bonded to one, two, three, four carbon atoms, and that will make it a quaternary carbon. And so let's take a look at these other carbon atoms on the quaternary carbon. This carbon atom up here is bonded only to the quaternary carbon, so this is also primary. And the carbon on the bottom is only bonded to the quaternary carbon. Again, this is a primary carbon. I'll continue with the chain. This carbon atom is bonded to the quaternary carbon, that's one, and another carbon, that's two. This carbon atom is a secondary. If you notice the next carbon atom, it too is only bonded to two carbons. So we'll call this a secondary carbon. And finally, the carbon at the end is bonded to only one carbon atom. We'll call this a primary carbon. Now, the hydrogens are classified based on the carbon that they are bonded to. Since this is a primary carbon, these hydrogens in blue are primary hydrogens. And in this example, we have four secondary hydrogens. In our last example, we classified carbons and hydrogens. Now let's focus on the alkyl halides and alcohols. In this example, I see one alkyl halide functional group. An alkyl halide, of course, is when a halide is bonded to a carbon chain. In this example, we have chlorine. Alkyl halides are classified based on the carbon that they are bonded to. In this example, the chlorine is bonded to this carbon. This carbon is bonded to one, two, three carbons. That makes this carbon tertiary. And that will make this chlorine a tertiary alkyl halide. We notice two other functional groups right here, the OH group. This is the alcohol functional group. Like the hydrogens and the alkyl halides, alcohols are classified based on the carbon that they are bonded to. In this example, this OH group is bonded to this carbon, and this carbon is bonded to two carbons, making the carbon secondary, and this OH group is a secondary alcohol. And at the end, we have another alcohol functional group. This alcohol is bonded to the end carbon here. This carbon is bonded to only one carbon. That's a primary carbon, and that's going to make this alcohol a primary alcohol. Next, let's learn about amines and amides. Amines are compounds in which nitrogen is single bonded to three other groups. And amides is when a nitrogen is bonded to a carbonyl group. Amines and amides can be classified as well. However, the rules are a little bit different compared to classifying hydrogens, alkyl halides, and alcohols. For amines and amides, classification is based on how many carbon atoms are bonded to the nitrogen atom. When nitrogen is bonded to only one carbon atom, we'll call this primary. When nitrogen is bonded to two carbon atoms, we'll call this secondary. And of course, when nitrogen is bonded to three carbon atoms, we'll call this tertiary. Here's the molecule dopamine. I'm showing the line angle structure here, but I also included some of the bonds just so that we can see them here. It's a nitrogen single bonded to other atoms. This nitrogen is bonded to one carbon atom. There is no carbonyl functional group here. There's no CO double bond. And so therefore this is not an amide, but this is an amine functional group. And amines are classified based on the number of carbon atoms bonded to the nitrogen. The nitrogen is bonded to two hydrogen atoms and one carbon atom. So we'll call this a primary amine. This molecule is called dimethylbenzamide. And I'm showing the line angle structure here. Here's a carbonyl, a carbon double bonded to an oxygen. I'm also showing partially condensed formulas here, the CH3 groups, just so that we can see that there are two carbons bonded to this nitrogen. And this nitrogen is also bonded to the carbonyl. So it's bonded to this carbon in this carbonyl functional group. So this is an amide functional group. And because the nitrogen is bonded to three carbon atoms, 1, 2, and 3, it is a tertiary functional group.